Welcome to today's webinar brought to you by Ascend.io. I'm Stephen Faig, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Innovating with AI, Harnessing the Power of LLMs, NLP, and OCR for Modern Data Products. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now I'm going to pass the event over to Paul Lacey at Ascend.io, who will be our MC for today. Welcome to the broadcast, Paul.
Thank you, Stephen. It's great to be here, and hello to everybody joining us. It's amazing to spend an hour with you today talking about the actual useful things you can do with AI today within your data pipelines to create the kind of modern data products that we expect to see going forward. So we're going to spend a lot of time today kind of going through some actual frameworks, looking at some actual code that you can write or that you can execute within your pipelines today to start building some of these things and making products that are extremely useful to your organization. So this is not a future looking thing. I just want to really set that expectation up front. We really want to anchor in the here and now and what is actually possible today. So excited to get into that content with you. Once again, my name is Paul Lacey. I lead product marketing here at Ascend.io. And I'm so excited to kind of walk you through and MC this presentation here today. But let me introduce the real expert on the call with us today, who is John Osborne, our field CTO at Ascend. John has a tremendous amount of background. Hi, John. Good to have you. A tremendous amount of background. I'll speak for you, John, because I know you're modest.
Leading, Thanks, Paul.
Leading data engineering teams at some really large and prestigious organizations. And actually, John, I think you call yourself a recovering CDO. That's right.
Yeah, recovering chief data officer, because all of us have to go back through the phase where life actually is good, and when you're done with that. So
absolutely, yeah. And so, John, I think we lucky to have you with us today for sure, both for your technical expertise, but also for your expertise running data programs in super large organizations and understanding the change management requirements and kind of other things that are required beyond just the code base, right, in terms of managing these teams. And so really looking forward to hearing your perspectives on these things. So really appreciate you taking the time.
Oh, thanks, Paul. And I'm so happy to be here. And this is one of my favorite topics. So I'm glad we have a stop time. Otherwise, I would just keep going. So
absolutely. There's a lot of great stuff to cover here. And let's talk about that really briefly, John, the agenda for today. So we're going to go through 3 steps to building modern data products. So first and foremost, we start with reviewing use cases for AI today. In particular, we're talking about in data products. So in data pipelines and things like that, where are areas that you can leverage AI right now. Then we'll talk about choosing the right methods for what you're trying to do. And I know we kind of gave away a few of those methods in the title when we talk about LLMs and natural language processing and optical character recognition for data extraction, stuff like that. But going through some of those things. And then we'll finally, and this is the most exciting part, we want to save tons of time for this because we're going to go in and actually build a pipeline that creates a modern data product using all of these different services. And so that's going to be super exciting. Of course, this is all built on the Ascend.io platform. That said, this is not a sales pitch. If you'd like a sales pitch, we'd be more than happy to connect with you and talk you through it. But today's purpose is to help you get some useful things working right now. And of course, you get the full benefit of everything we're going to show you on the Ascend platform. But these are concepts that transcend any one particular platform that you might be working with and things that you could kind of put into production right away. And that's our goal here today, is for you to walk away with those kinds of insights.
Yeah, no, it's great, Paul. And I think if you were to state those three kind of agenda points a different way, the first way is I think a lot of folks don't realize how many options are available for AI. When we say AI, like what do we actually mean? And then from a method standpoint, like how do you and when do you introduce it into your environment? How do you manage it? How do you maintain it? How do you deploy it? How do you test it? Those kind of topics are really, really important to go through. And then the last one is the operationalization of the whole thing. Like it's one thing to have a cool Python program on your laptop that does something amazing. It's a whole other thing to put that thing in production on gigabytes or terabytes or huge data sets and actually have it operate effectively, producing results that you want, and then also like be maintainable. That's the engineering side of pipelines that I think we're going to hear a lot about today. So I'm a very practical kind of leader in that, theory is awesome, but we've got to turn it into something that we can actually implement. So.
Yeah, absolutely. Well, without any further ado, John, let's get into it. So we want to start by talking about the different AI use cases, right? And I guess the first thing is a bit of, kind of scene setting for everybody in terms of what's going on out there in the market today, right?
Yeah, absolutely. I think Gartner says 85% actually of AI LLM bucket those things all together. Projects fail to deliver. And by deliver, we mean deliver value like in production and actually get something done across the goal line. And I think lots of organizations, probably most organizations, go through this learning process where you're assembling your data, you're doing this MLOps thing, you can see in quotes there, and then you're building something valuable or something that you perceive to have value or you think you have value. And then you're left with the question of like, okay, this thing is important. It's producing an output that we really want to hang our head on. But now what? Like, how do I get this to production? Like, how do I integrate this with all of my other legacy systems? What about all the other data that needs to come into play before and after this model? And what about this model do I need to report on and control with and do all kinds of things like that? So I think in general, they're super difficult to deliver. Again, getting back to the laptop description, if you've built a really cool model on your laptop and it does something awesome, that's great. But this is where lots of orgs go into a re-engineering phase where they pick that up and they have to maybe re-engineer it, or they have to like somehow include it in their overall technical change management process in their data environment. And that can involve oftentimes a reduction in the value of the model, or things like that happen along the way when kind of the older school methods of taking a data science project, throwing it over the wall to engineering and have engineering implement it. This is why that 80% or 85%, according to Gartner, number tends to be a lot larger than people would think it is. So I know I've personally had a project or two at least that went through this exact scenario of like, oh, this thing's amazing and everybody can understand how this model helps a call center theoretically get better, but how do you actually realize that benefit? And that's where the challenge lies, for sure.
That's where the rubber meets the road. Yeah. And I think, the purpose of today is to try to help people get over that hurdle, right? So how can we
absolutely
stuff?
yeah. I mean, and so I took lots of people have seen this slide. If you Google like data maturity and you click on images, you'll see like a zillion versions of this. So I took a little lighthearted approach here, putting my own content here. But it is true that data maturity is a thing. Even if you want to ignore it, it's still a thing, and you still have to manage it. Most people go through this like progression of maturity journey or whatever you want to call it, and everybody wants to be on the right side there, where you're this amazing data-driven organization and you're taking advantage of all these things. And so when these new things like Gen AI come up, like ChatGPT, like, how do we use this? Oh, this is amazing. We should use it. You have to really pay attention to this diagram, because you think you want to be ready for it, and I can see how I can make a business impact with these tools. But in reality, you're probably further on the left on the diagram than you want to be, or even if you've never done an analysis, than you think you are. And that causes problems. This is, again, one of the bases for the failures in delivering business value, but it also speaks to the capabilities that need to exist within the data architectures of companies that want to do AI and ML at scale in production in a serious way and delivering serious business value. The maturity journey is a real thing. So I'm not saying that you have to necessarily be all the way to the right or even halfway to the right to be successful, but I think acknowledging where you're at will help guide investments and strategy so that you can avoid running into brick walls like, oh, I don't have an automation system, or I don't have a orchestrator that can help me at scale like this. Like, these are things then that perhaps you have to build into your data plan. Not to be salesy, but in Ascend's world, like, we kind of skip the line up to the right side a little bit with Ascend for sure. And this is where AI and ML customers of ours tend to get a little bit head start, because we take care of a bunch of these things automatically for customers for sure.
Yeah, it's
I don't know. What do you think, Paul? Do you think dashboard purgatory is a good place to be?
Having been there and several companies that I've been in, and also marketing programs that I've run over the years, no, I can say it's not a fun place. Yeah, a lot of hand wringing and a lot of late nights, and ultimately, if you can find a solution that's going to automate things for you, so you don't have to spend as much time to figure out when things break, how to fix them, that kind of stuff, it's 100% the right move. And also, speaking, you and I are both former engineers, John, and the first inclination with a lot of this stuff is like, let's run out, let's grab some, a notebook environment or something like that. Let's test it out. Let's do a hello world. Oh, look, wow, this is so awesome. And then, let's just let obviously we should just push this out everywhere. Right. And then that's where I think sometimes the hiccups happen.
Exactly where the hiccups happen. And a lot of these hiccups then happen because we're doing the AI or ML work. When I say AI, by the way, I mean like kind of the gamut of Gen AI and LLM and like this whole like help me do calculations at scale area. But lots of organizations end up putting the work in the wrong spot in their architecture, either because it's the only thing they can support, or because they're not organized in a way that, or like organizationally, they can't support it in the proper position, or they just didn't know that all of these different positions exist. So I've seen this before where, data engineering kind of loads all this data, and the data science people go off and do their thing, and then everything ends up being post-pipeline, like to the right of the work. In reality, the early pipeline and mid-pipeline implementations of these technologies can really, really lower costs, increase data quality, and make massive impacts. So an early pipeline example, for example, we're going to do document AI through Snowflake. This is an early pipeline LLM model that allows you to extract data out of unstructured formats like PDF or a Word doc or whatever. Mid-pipeline models are things where maybe you've ingested the data and you have the data cleaned or whatever, but you need to pre-process it before you send it off to some other model. These are maybe mid-pipeline implementations. And then post-pipeline implementations might be something more like a real-time implementation with a call center app. Like, I'm on the phone with somebody and the model's running and it's analyzing the text that's coming out and it's giving me suggestions of like potentially helpful websites for the customer to go to or whatever. That would be like a good example of a post pipeline implementation, in that I've accumulated all this value through my entire data pipeline. I know the customer, I know the business, and I'm prompting this model and I'm getting the decoded data, and now I have this like actual answer I can give out at the end of the pipeline because of it. But anyway, the point being that there's places in the pipelines where the models can add value. And I think it's important to understand, even if you can't put it in the right place, you should at least acknowledge where it should go in your architecture, and then understand that you're compromising if you're not putting it in the correct spot in your architecture, because that'll have impacts in your implementation. So you may avoid a failure if you're clear about what it is you're trying to do. Mm-hmm. And then when we look at kind of early pipeline, this is just a quick overview of whatever I said, but unstructured stuff in the early pipeline, NLP, OCR, maybe some models there that have a lot of value as data comes in. Mid pipeline, classification and sentiment stuff is classic mid pipeline work where I'm taking data off a PDF and now I'm trying to figure out like what did somebody write and was it positive or negative, for example. So it's sentiment scoring and things like that. And then, of course, on the post-pipeline work, maybe I'm fine-tuning results. Maybe I'm giving real-time responses. Maybe I'm doing fraud detection. Maybe I'm doing all of those types of things, right? So I think as we look at this, there's definitely some case to be made that certain technologies and certain implementations fit there in different spots in your data pipelines. Again, if you don't have the capability of moving components from left to right in your pipeline, or right to left, or to move it around, and you don't have a framework that you're actually implementing with the technology, this can be really difficult to do. Because if you're writing a lot of custom code, like moving something from a right end post kind of processed into the ingestion side can be really difficult. In fact, it might be a brand new project. In the Ascend world, that wouldn't be the case at all. And we can talk through that. But again, it's important to acknowledge where you're at.
Yeah, and I think, John, that also that a big call out for all of these is the accessibility with generative AI models that are coming out today. Like, you and I have talked through this many times, where it used to be really painful to do things like OCR, data extraction. You used to have to set up templates for each document that you wanted to profile. And, God forbid, there's a new document that comes to the system because it shut everything down for a couple of weeks while everybody goes back and tries to re-architect some stuff. Or NLP, for example, used to be a really high overhead. And now one of the things that's really possible that we're going to demonstrate today is with these models that are coming out, it's just an API call that you put in your Python script to say, hey, call this model and get this, ask this question. Can you score this for me? A sentiment analysis, or get the result back. And then you can literally populate that into a table in your favorite data warehouse, and you're off to the races, right? So, I mean, the barrier to entry to all this stuff has dropped really, really low.
It has. There's so many more accessible features available, 5 or 10 years ago. I mean, AI stuff's been around for 30 years or more, but in the past couple of years is where the accessibility has really become apparent. So now you can sign up for ChatGPT for $10 a month or whatever, and you can run this LLM model. It's amazing and does all this really interesting stuff. Prior to that, you could have done it, but you would have to have a little server farm and spend a bunch of time training, and like, oh my gosh, it's too much for a little organ or even a mid-sized corporation to take on. It's too expensive. The value is tenuous, but for $10 a month, absolutely, I'll do it. So I think the availability of these APIs has really opened up the floodgates for how to do this stuff. And I think this is where tools like Ascend really help out. It's like, okay, great. Like, you really want to use this model and it's accessible and you can call it, but how do you combine it with the rest of your stuff? And so this particular diagram really kind of hits that nail on the head, which is, this blue box here that contains MLOps and a trained model. This is kind of the toil work of creating these models, which are now readily available, like in Snowflake and Databricks and like BigQuery. And these models are callable just by normal humans. Like, you don't have to be a superstar anymore. But there's still all of this other work that you have to do in your data environment to produce an actual business valuable output. So the business value is not the execution of this model as a singular function. It's the combination of the inputs to that execution, the other data that comes in to combine with the outcome of that data, the cleaning of that, and then the actual formulation of the business outcome. So we used to talk about data products in general as something that a pipeline would produce, and now it's like an AI augmented data product. So now I have this data product and it's got a bunch of AI that was used to build it, either early in the pipeline through ingestion or mid pipeline, because I did some retrieval augmented generation or whatever to do some prompting, or all of the above. And now I'm creating these data products that are better, frankly. These AI things can do work that before was maybe impossible or unattainable. Now all this stuff's approachable, and now I can continue to build even better and better data products. The caveat, of course, is that at scale, automation is key. Right? If I don't have a way to maintain these pipelines, I might get version 1 out the door, and I might get model 2 in production. I might get model 3 maybe, but can I have 100 models running? Can I actually be agile in delivering data products that combine all the outcomes? Probably not if I'm writing my own code or if I don't have a platform. You probably get stuck, which is okay. It's all solvable problem. But if you got one step past hello world, the next question might be, okay, how do I scale this thing? And this is where tools like Ascend really come into play.
Absolutely.
I think doing a very simple model on your laptop is really cool, but doing terabytes and terabytes of data in the cloud is not going to happen on your laptop. So,
for sure.
What do you think, Paul? Should we move to some demos and see some actual action?
I thought you would never ask, John. Yes, let's do it.
I'm ready to roll, Paul. So at Ascend, we love all of our data plane vendors. By data plane, I mean compute and storage vendors. So Snowflake and Databricks are the two we're going to use today. They provide a computational engine, either through SQL or Python or some other language, for example. And they also provide storage. So they have sophisticated ways to store data. Snowflake's got some proprietary stuff, which is awesome. Databricks has also some proprietary, but also some readily available open source tools. Of course, there's all the other data planes that we support too. BigQuery being one, and a few others that shall not be mentioned right now. But suffice it to say, we have a high opinion that you should use a cloud technology. We have a very low opinion, if no opinion, on which one you should use. That's a customer decision. And we simply allow you to configure each one. So that being said, I wanted to pull a couple of pipelines together for this demo. One is specifically for Snowflake. So Snowflake has a really cool tool called Document AI. It is a processing engine that can interpret documents like PDFs, Word docs, images, that kind of stuff from storage in the cloud, and then it can you can ask questions of the document, and I'll show you what kind of questions we're asking. But like if I have a mortgage document, for example, for this demo, I can ask the document who the purchasers are, or what's the MLS number of the property on the mortgage document, and the document AI function in Snowflake will pull that data out for me. and make that awesome. In the Databricks demo, I am actually using ChatGPT to do some prompting and create some emails, and using the venerable, the natural language toolkit Python library, which has been around forever, it seems like. But combining those two into a single demo, because then when you see how that actually works, you can see the level of sophistication that pipelines, in my opinion, should have to combine all these great technologies together to make them work. And yeah, could you take both of these demos and do them by hand? Absolutely. Could you do it at scale and maintain it? Probably not. So, so let's dive into this. Clearly, these are contrived demos for the purposes of demonstrating how the technology works. Obviously, there's other ways to do this. This may not be the most optimal way to do it. I'm sure there's optimizations even if you did it this way, but with those caveats, let's kind of get started. And we're going to start with Snowflake, the Snowflake demo. So what I'd like to do is go over just from a visualization standpoint about what the pipeline is going to do, and then we'll hop over to the actual pipeline so you can see it in its full glory in the Ascend world. And then we can come back here and kind of talk about it for a minute, and then we'll go on and move to the Databricks demo. So the way I like to do this work, just in general engineering, is we have a business question to answer. So here in our Snowflake ecosystem, we have some mortgage PDF documents. So these are structured, well, they're PDF documents that are forms. Basically, it has a bunch of fields on them. And the question I want to ask is, if people are sending me mortgage application documents, I would like to know if somebody on this document has previously purchased a mortgage with me. So are you a repeat buyer or are you the first-time buyer? And the reason for that might be different communications. I might send you different snail mail. I might call you and offer you other rates or whatever. But the business question is a real thing, which is like, I want to know, have you bought from me before? So the layout of the pipeline is really pretty simple. We have document coming in to Snowflake. The document actually gets read out of an S3 bucket, but regardless, the document AI function then gets called. This is a trained model that Snowflake supports and that we put a few questions into. The outcome of that model is a JSON document, and that document then needs to be flattened. So JSON in itself is a great data format, but it's not really relational until you flatten it. So flattening the data is really important because we need to combine business data with it. So in order to know, have you bought a property from me before, I need to know who you are. And then I need to take all of my previous buyers and combine those two lists, and then I can figure out who my existing buyers are and who my new buyers are. So it's very simple to talk about at this level. It's a whole nother level to implement this at scale across hundreds of thousands or millions or frankly billions of documents. So with this being said, hopefully everybody's clear on the question I'm posing. I'm going to switch over to I'm going to share my screen over here, and we will start this one. Great. You can see that, right, Paul?
Yep, we've got it.
Okay, awesome. So really quickly, for those who have never seen Ascend IO before, the teal boxes represent some ingestion technology. So in this case, I'm reading in PDF documents from an S3 bucket into Snowflake. This is a customer master file that I'm reading in also from S3 into Snowflake. So the customer master, for example, has a schema, and there's records attached to this document that are getting read into the system. So the teal is reading in. The red boxes are then transformation activities. So this is where the rubber meets the road. And the very first thing we did, we're going to talk about this in a second, but the very first thing we do is we read in the PDF, and then we actually call the Snowflake model. So if we were to look through Snowflake documentation, we created a project in Snowflake's document AI called Mortgage Demo, and then we call this predict function with the document URL, and then from there we actually get data out of it. And the data we get out of this call, which is really simple, by the way, given all the work it's doing, the data we get out happens to be a JSON document. So you can see here I have the buyer score. So the buyer for this document is Frank. You can see the relative scores of how accurate the AI thinks it is. You can see there's a second buyer here. There's an MLS number. There's an offer date. There's a parcel number, and the seller's available also. So you can see the outcome of this particular function is a JSON document. So I left that as a JSON document as the outcome here, because I wanted to highlight the fact that we can then take this JSON document, and then you're going to have to flatten this document somehow. So if we look at how to do this in SnowSQL, for example, we use this lateral flatten technique to take the JSON document, flatten it out, and to actually extract the buyer MLS number and all of that information. And if you look here at the records, you can see, we have some flattened data here, and I have my original document. I have offer dates and all kinds of information available to me here. If we actually use the Snowpark implementation, which happens to be Python downstream, it's Python. It's a little uglier, but it accomplishes the same exact task. So at the end of the day, I have a schema that has the buyer name, MLS number, and offer date in it. And then this is where the rubber meets the road. So now I've done three steps really, adjusted the data, called my document AI. I'm using Snowpark here to decode the JSON document. And then if you remember from the previous slide, I have to combine my customer data. So this is my customer master. These are all the customers that have previously purchased properties with me. So then if I ingest this data, which happens to be a little CSV file with some records in it here that I've ingested. If I combine these two together in a SQL statement, I can use some of the other language available in Snowflake to actually make that combination. So with my customer master data, I can then select an edit distance or a Jaro-Winkler similarity. There's other AI available for all of this type of joins. Remember, I have two names that I'm trying to join. This is not a trivial just, if this equals that. You have casing, you have spelling, you have all kinds of issues with pure names. And what I'm trying to do is figure out, as long as my score and similarity is good, then I should get some outcomes that work for me. So this looks like buyers that have bought from me before. So I know I have big machine records in my master file here. This is the buyer from the document. So you can see there's some casing differences and things. And I have some MLS numbers that they're purchasing. So this is the outcome of this query. And then, of course, I can take these and write another query that gives me only my new buyers. So if your buyer ID is null, it means I couldn't find you. So you're a new buyer then. So you can see if I look here at the records, these are all my new buyers that didn't exist in the other data set. So you can see in a few steps here, using Ascend, we've automated the ingestion of all of this. In fact, if I were to go and make a logic change here and update it, we can see that Ascend will go ahead and not only update this, but then pass that logic downstream. And that's true for new documents coming in or new master data. Ascend will manage all of the synchronization, orchestration, if you will, downstream for this particular data flow. One of the things I want to point out here, I want to get back to this. This was actually the original version of Document AI that Snowflake published. And I was going to remove this, but I left it around because this is a great example of how pipeline tools and platform automation can help, in that Snowflake changed the method signature for the how to call this. It used to be called document extract features. Now it's called predict. And this object construct was pulled up into their training data, which it's beyond the scope of this talk, but these questions are now have been pulled up into a different component. So if we look at then doing this particular work here, you can see it's a different function that I'm calling. And so with Ascend, then I'll just edit this here. We can see that changing the upstream lineage essentially of what we're doing is really simple. So when Snowflake, so you can see this is going to error because it's blocked. When Snowflake made this change, I simply created a new box and then repointed pointed these back at the new version 2 API, so that the components all came up to date. So it was very easy for me to manage a change, even if a vendor changes a method signature, which happens quite a bit in a lot of these private preview, but even sometimes in production. So, all right, Paul.
Super.
Was that a lot to handle for Snowflake?
That's a great demo. Yeah, no, and I really appreciate you walking through some of the nuances there when it comes to long-term ownership and maintenance of these. John, I think that's the big one, right? That gets a lot of people is it's very easy to stand up a few of these and then prove some value. But then when things change and break and drift and everything that happens in the real world, and you find your engineering team slowing down oftentimes at scale when you're having to spend so much time on these things. I think the real crux of the thing is not just being able to build these products, which is awesome, but also being able to keep building more new products all the time, as opposed to constantly getting sucked back into the maintenance of the existing products and fixing things and playing whack-a-mole. So, and It's awesome.
We didn't even get into or cover audit or source control or any of that type of work.
Perfect. So let's take a look at another one.
That's another topic. But let's go. Let's talk about Databricks now. So that was really great on Snowflake. Let's talk a little bit about Databricks. So if you remember back here, we have this this demo here that I'm doing, combining Gen AI model, ChatGPT actually, with the natural language toolkit to produce a solution on Databricks. So this is what this is going to look like. I have some sources of video reviews, both from Amazon and IMDb. So if I'm a marketer and I want to respond back to cohorts of people who have given different reviews and scores, or if I want to give feedback to the producers of movies or advertisers or whatever, I have the point is I have all these sources of data, but I need to combine them and normalize them. Lots of people call this like data cleaning. I think it's actually more engineering the actual pipeline than it is data cleaning. But you have multiple steps to go through, and there's multiple data sources, right? But at the end of the day, what I really want to do is I want to write an email back to the people who gave feedback that's either positive or negative. So it's like, oh, if you loved my movie, I want to send you an email that says, hey, thanks for loving my movie. Maybe you'd like this other movie. Or if you hated it, like, hey, I'm really sorry about that. Can you click here and please give us a survey to figure something out? But the point is, I'm doing some realistic business scenarios that I want customer feedback, and I'm gonna respond to it. And you can see even in this super simple example, I have no less than 4 inputs to this pipeline. But then I have all this work I got to do to create not just the actual review data, but then because I have ChatGPT, I can use ChatGPT to help me prompt in different ways and do a little RAG basically, and use the prompting technology available on ChatGPT to actually create the emails and personalize them a little bit so that they're not so canned. Because presumably I know a little bit about you, person, so let me give you some feedback. So the business problem here is responding to reviews with a Gen AI generated personalized email based on the sentiment of the person of the comment. So a couple caveats here. One is the IMDb data already comes with sentiment data. So it's already done for me. Awesome. It's not the same outcome as the sentiment that I'm going to calculate from Amazon, so I still have to do some translation. So it's not good enough that it's just there. I have to actually convert it. And I think the conversion is from 0 to 100, 0 to 1. It sort of depends on the scale you have. So you have to normalize all this data. And this is all of that, what people loosely call ML ops work. We're doing that here. But then the Amazon data is like literally just raw natural language. There's no scoring, there's nothing. It's just raw data. So I'm running this through the natural language toolkit. Sorry, stumble on that. And then using Vader to do the sentiment analysis on the language for each one of those, and then combining all that data together into one data set so that then I can do this. Now, again, this is a small example, but imagine maybe I had hundreds of inputs now. Maybe I had Twitter feeds or LinkedIn profiles or Facebook or like any number of input sources. Imagine at scale trying to do this, right? So this is super simple, but scaling it up would be a challenge if you're running your own software. So let's have a look at this. I'm gonna share the Databricks version here. And again, we love our Snowflake partners, but we also love our Databricks people too. So we just love all cloud compute and storage, I guess. So based on what you've seen in the sort of Excalidraw version, you can see I have these reviews in here. So the IMDb scores, the Prime, Amazon Prime scores. I have marketing preferences, which are like, if you told me not to send you an email, I need to respect that. And I have prompt information. Prompts would be like a literal prompt that says, for ChatGPT, that says, compose an email to apologize for poor performance, et cetera, et cetera. So this is literally a prompt that I'm giving ChatGPT so that ChatGPT can respond properly. And then I'm going to generate the email through some code, which we'll go through in a minute. And I'll show you how this works. And then we combine all of this at the end to write out the email bodies to an S3 bucket. I didn't have the blue or purple in the first diagram. And for those first timers at Ascend, blue is data sharing. So this is data share that ends up in a data catalog that then you can select from to do downstream processing with. Purple boxes are data that's leaving the architecture. So in this case, it's leaving our Databricks environment. It's going out, in this case, to an S3 bucket. It could just as easily go out to SFTP location or another database, or you could send it to Snowflake. You could send it to wherever you wanted. But that's what these two colors mean. So let's review here. Again, the IMDb scores are already scored. So when we look at the records here, I get I get the raw text, but then you can see here I get the sentiment already scored here, negative and positive. I get the movie and the email of the person. So that means I have to do some transformations. So this is a really simple transform, but because my scale for positive and negative is actually 1 and 0, not positive, the word positive and negative, you can see I'm doing some scoring, some simple transformation here, which is simple, I agree, but also needs to be orchestrated and executed. And if I change my business logic, and do something like this, that's really interesting. For example, because maybe they changed the upstream rules, now I have a platform that can actually execute and make these updates happen. So this is a real simple one, and you can see I'm accumulating all the sentiments here through a union query, tracking the IMDb review source here with a union with Amazon sources. So I'm doing a union query here to combine those two data sets. Things are much more interesting on the Prime side in that we have to, first of all, process the text. So the Amazon Prime data comes in as a JSON document. So we're processing that text, and we have to do a little pre-processing to tokenize it. And then at the end of the day, we end up with the review text pulled out into records. So this ends up being the review text that comes from the Amazon data with a positive or negative score. The movie name, I think I grabbed the email, and then this is the text that was used to create the sentiment. So this is the text that was used from the raw sentiment here. Then when I just take the actual raw text, I can use my NLTK model to actually perform the sentiment analysis. So we're using Vader here, and we're firing up an analyzer and getting my scores and attaching the scores to the record set. So Python people should hopefully feel like this is really concise and good and easy to read. At the end of the day, I end up with a data set that looks like this. I didn't have to create a table. I got my score here in a decimal, and I converted it to ones and zeros. I didn't have to create tables. I didn't have to alter tables. I didn't have to do any of that. The platform takes care of it. And then, of course, both of these outcomes get unionized into an all sentiments database. I created a data table. I created a share for that because I thought maybe downstream a lot of people might get a lot of interest in using this data downstream for other analyses. So I created a quick share for it there. On the so Paul, does that make sense on the sentiment side?
Yeah,
so we've used Databricks SQL. We've used a couple of flavors of PySpark here to use those models, and we've used some more SQL to create the data set that we want.
And it looks like, John,
get a little.
Sorry to interrupt there, John, but it looks like it's pretty easy to import these third-party libraries, right? You're just kind of referencing them in the like notebook text and in the code and
I can I kind of skipped over that, but if I hit the edit button and we look well, I'm sorry, it's at the connection level, but we can create the import here for the actual sentiment analyzer. If in fact NLTK is already in Databricks, that's why I forgot about that. So I just had to import it here. The reason it's imported here is because this is a UDF which gets parallelized out. So we use Spark for this. So there's a little few things going on here that are important to understand, but from a parallelization standpoint. But it's really easy to use any of the libraries that are preloaded into your images. I think if we pulled up the Databricks environment, we would see that the container had an LTK already loaded in it. For sure.
Makes sense.
Thanks for asking that, Paul. Again, Ascend is like, we're a common layer across all these platforms. So all of those nuances around how to manage those types of dependencies, for the most part, Ascend takes care of that, or at least it makes it very clear where you actually do that work. And then Ascend can take the benefit of all of that. So let's drop down here to maybe a little more interesting work. This one's boring, so we'll skip marketing preferences. But the prompt part is super interesting, and I put this in because I wanted to make a point that in this case, I'm using the OpenAI endpoint, and this happens to be a REST endpoint. So I'm actually calling a REST endpoint in the middle of a pipeline. So for lots of people, and we're doing it with a UDF here for parallelism. So for lots of people who are data engineers would understand that if I had millions of documents coming through or of prompts coming in, and I wanted to generate emails, I would need to do that at scale, and I would need to have a way to implement all of those REST calls and things. Ascend provides a framework for that to exist. So this particular transformation method expects a data frame on the way out. We'll go ahead and parallelize that across the execution, depending on how the Spark cluster is configured. And then in this case, I'm returning the data with a new column at the end, which is response JSON that came out of the OpenAPI call. So I'm retaining the whole response from OpenAPI. So you can see this would be some JSON that OpenAPI responds with. This is the 3.5 model. But you can see the data I want is in here. Like here's the subject for the email, and then here's the actual output text. And this is all generated on the fly by ChatGPT, which is really cool. And then I can take the final step then is to take all the sentiment data, all the emails, and the marketing data, and then create the actual output, which is I want all my sentiment data with all my emails and marketing preferences where I have a preference to send an email. So if I don't have an email address and I don't have, and I haven't told us not to send you an email, then all of this will happen. So this ends up being the email data. And then of course we're writing this data out to an S3 bucket because there's a mail merge process downstream theoretically that's actually going to do it. So at the end of the day, I'm writing out a file that has a review source, the review, the sentiment, what movie, what's the email address, and then what's the response to send out to the consumer. So in just a few boxes here, I've combined what would normally feel like a very sophisticated, complex set of tools. I've combined them in a way that becomes highly automatable. And what I mean by that is if I were to change, I think you saw me do it before, but if I were to edit here and change some text and make a rule change, Ascend is going to automate not just the execution of the thing you changed, but all of the things downstream and nothing to the left. So if I've already spent the money to do the ingestion and the text processing and the natural language work on certain data sets, and I only want to process the stuff that downstream that I've changed, then Ascend makes that super easy to do. Not to get salesy, but this is the stuff I wish I had. This is why I'm a recovering CDO, because I didn't have a tool like this, if you know what I mean, Paul.
Yeah, well put. Well put, John. Yeah, I mean, it's great. And, in the span of just a couple of minutes, obviously writing the code, banging on a keyboard took a while, but being able to create these modern data products now, like we can do some really cool stuff with our data. And this is not in the theoretical, right? These are things that people can start to do right away. And there's the blueprint right there, right? Just 3 steps to understanding, what you can do with your LLMs, the right method to use, and where to put it in the pipeline, and you're off to the races. Mm-hmm. That's awesome.
Yeah, and I think the thing that's for the architects maybe that might be listening, the important part that I glean out of a lot of this is there are the right tools for the jobs out there. So there's dozens, if not hundreds, of LLM models. There's different ways to implement natural language processing. There's all kinds of things out there. You may have one maybe for a medical analysis. You want to use the Amazon, medical dictionary. You might have a custom dictionary for a different thing that's written like in a slightly different language. You might have all of this conglomeration of these things that all together produce the solution you want, but what you're lacking is the flexibility to then pipeline it all together. And that's one of the things that gets me super excited about Ascend's possibilities, in that you're no longer limited by the cloud or by the compute vendor, or even by the language, frankly. Python and SQL are now essentially first-class citizens in most, at least most commercial cloud databases. So all of that's available to you. What's missing is the toil of creating tables and wiring it all together and all of that. And that's where I think tools like Ascend really enable this. So in a way, the ChatGPT revolution is highlighting even more how much automation you actually need on the things that you didn't realize need to be automated.
Yep. Well said. Well said, John. Well, thanks for that. And Encourage folks that have questions about the Ascend platform to find us online at ascend.io, and folks that have questions about this webinar, now is the time. So why don't we get into a little bit of Q&A here, John?
Absolutely.
Sound
I think
good?
I'll probably come back in
I love it.
here. Oh, fantastic. Thank you, by the way, both Paul and John, for that fantastic presentation. We've got great attendance today, and we do have a lot of questions already that we have to get through. And yeah, folks, any additional questions, please send them our way while we have John and Paul captive here with us online. So first question, sorry, the early pipeline slide went a little quickly. Does that encompass importing cell-based data? Thanks.
Yeah, I could take a stab at that one, John, if you want.
Sure.
So the early stage pipeline applications, certainly, importing data from various sources is very important, because at the end of the day, if you can't get your data to the cloud, you can't do anything else with it. So we do have quite a few customers that are using connectors that either pick up files from an S3 bucket and the CSV format, and then import them into a columnar-based data warehouse, cloud data warehouse. So there's a lot that can be done there for sure. And when it comes to taking that data, you can take that CSV data in as a blob if you want, or as a JSON object if you wanted to do some sophisticated things with it downstream within LLM and NLP type capabilities that we demoed here. So I guess short answer is yes, absolutely. Early stage pipeline does imply the ingestion of the data into a cloud data pipeline, but maybe not so much the LLMs playing a role in the ingestion of that data, but the LLMs playing a role in doing other things with it downstream.
Understood.
Although, Paul, I do want to point out that LLMs are helping now with actually just doing the analysis and figuring out how to do the ingestion faster, or without having to write any code, just let the model do it for you. So,
good point. Yep.
Yeah, it's very interesting.
Okay, so on to our next question. Can you expand a little bit on what you mean when you said the model is not the valuable business product?
Oh, absolutely. Let's go back to that slide here, just so we have a little visualization. Oops, I think I missed it. I did, yeah. Yeah, so if we look at just the model on this diagram, it's what's encapsulated in this blue dashed box, right? So I have some ML ops work, which is the traditional cleaning, cleansing, loading stuff, training, and then I have this model that's actually producing some output. Just like in the case of Document AI, the outcome of this model is rarely, if ever, the direct output for the business. The outcome of that model, like in Document AI world, it's a JSON document. You're never going to send that JSON document anywhere to do anything useful with. You have to flatten it. You have to pick things out of that response that you want. You're going to filter it for poor scores. You're going to do a bunch of work on that document. And so when we talk about valuable business output, 99.9% of the time, it's not the direct output of the model. That model has to go through some processing and be combined with other information, even if it's just business logic around what scores am I willing to tolerate, which scores am I not. All of that work is what results in your actual outcome of your business data product. So hopefully that clarifies what we mean there, or expands on it.
Absolutely. Thank you, John. I see another question here that we'd like to tackle. Is ChatGPT model being hosted locally or on some external place like Hugging Face?
So in the example I gave, I won't take the time to pull it up again, but in the example I gave, I'm actually calling the live API that the public API that ChatGPT has available. So I was just using the public model. if you had your own model running in your own sets of containers, or you wanted to use Hugging Face, or however you wanted to do that, all of that's also possible. The point is the interaction between you and wherever that model is hosted is generally some sort of API, whether it's a REST API or a SQL endpoint in the case of Document AI, or a Python library like for for the natural language toolkit. The point is there's some sort of API that you're able to execute, and the hosting then becomes super flexible. And that's, again, where the individual writing the question actually makes the point by asking the question, which is like the value of your pipeline vendor staying flexible becomes clear as soon as you want to change from one hosting to another for cost or for performance or for better outcomes for one thing or another. In our world, that just means pointing to a different API and having a slightly different language.
Understood. It's amazing how much time flew during this event. We're already at about 2 minutes past the hour, but everybody has largely stayed with us after the bell, and we certainly appreciate our attendees today for that. I'd like to squeeze in one more question, as I always do. And John, we can start with you, and Paul, please feel free to add in. If there's one thing that you'd really like our attendees today to walk away keeping in mind, what would that be?
Go for it, John.
I mean, I think the one thing that if you're in like an architect cohort where you're trying to figure out how to answer the business's question, which is like, how do we use this stuff to our advantage? Because it seems like everybody else is using it to their advantage. I think the thing I'd want those architects to leave thinking is that they should be focused on how to wire the models together and how to combine their business data, and not be worried about orchestration and creating tables and even what cloud database you're using. Like that stuff, you don't have time for that. You're going too slow if you're worried about it. You just need to make choices, and you need to let these tools operate, do all the toil-based activity for you, and do the automation for you, so that you can focus on figuring out, should I be doing this model at the beginning of a pipeline or at the end of a pipeline or in the middle somewhere? Those are the important decisions to make, and sorting through the hundreds of options for you for your business and your scenario. That's the stuff you should focus on, and you should invest in pipeline software that allows that to be true, where you can spend most of your time worried about the important stuff.
Yeah, and
Paul,
I think that
you'd like, sure.
Yeah, that's a great kind of point to end on. And the other caveat that I'd throw in is the world of AI is a very different world than the one we've been living in for the past 20 years, and data integration with columnar based lookups and things like that. And so the amount of third-party libraries that exist today to help you accelerate your adoption of these capabilities is just exploding, and it's only going to continue to grow. So making sure that you have a modern platform behind you that is going to enable you to adopt these things at speed is going to really serve you well in the long term. And secondarily, making sure that the platform doesn't get in your way with archaic kind of limitations from the previous era, where we were primarily thinking about doing lookups and joins and SQL-based queries, versus what we demonstrated here today. A lot of stuff was in PySpark or Snowpark or other kinds of Python frameworks. Those are becoming more and more common now, especially when we think about data pipeline orchestration. And so it's really important to make sure that you have a platform that can support that, because I think, unfortunately, some folks are based on some legacy technologies, and that's going to hold them back. So that's the thing that I would add to that, John's excellent answer, which is, think about the overall architecture of things and don't get mired in the weeds.
Well, I would like to give a huge thank you to both of our speakers today for coming on and sharing their insights and expertise. Thank you, Paul and John from Ascend.io. Really appreciate it. I know there were a ton of questions today, and we did not get to all of them. I am going to share them with our speakers, so they could hopefully follow up with you, help with those questions. If you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It's not going to change. And this event will be archived. It'll likely be up probably by tomorrow afternoon. We will send you an email notification so you'll know as soon as it's up. And once the archive is posted, if you would like a PDF of the deck, you can go to the handouts section once that archive is live to grab it. And again, as I mentioned earlier, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on January 31st. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.